All right, I'm back. We're on notes 20 now, so we're moving along. And these are still about limits, and we're just going to dive deeper into the ideas, get better at it. That's our goal. We're going to learn a lot of algebraic things that we can do and new ways to think about things. So this first page is pretty informal, and all we're trying to do is figure out, like, kind of intuitively, like, what are we doing here? So the question that we're going to answer is we're going to figure out what the given function should evaluate to at the indicated x value. So this is another way of saying, like, basically, like, not what's the limit, it's saying, like, what should the function have been, which is the same as saying what's the limit. But this is like you give it to an algebra 1 student and you say, like, what do you think the value of the function should have been? And they will argue with you that the things we're about to get make the most sense because they're right. They have this intuitive sense of a limit. So let's see if we can work these out, which I'm sure we can. So first function, I mean, look at this thing. So this function, like x minus 2 over x minus 2 is basically just 1, but it's only 1 when x is not 2. Because if I take 2 and I try to sub it into the original, I get 0 on the top, 0 on the bottom. That's indeterminate. So we can't decide what it is. It's 0 times something should be 0, 0. You can't divide by 0. And then something over itself, 0 over 0, should be 1. We have 3 things that, like, all sort of make sense. So it's just indeterminate. We can't figure it out. So if we simplify it, though, this function is exactly the same as 1 at every value that is not 2. So why would it not be 1 at 2? Like, it makes no sense. It makes sense, but you know what I mean. Here, here. Perfect. That's a perfectly horizontal line. Let's do it again. Not great. So that's at 1. And I'm like, just fill it in, right? This is a removable discontinuity. So I'm going to say that f of 2 should be 1. And the reason that it should be 1 is that this function is 1 everywhere. It's 1 everywhere except there. Why would it be anything different? And that's kind of the argument that you have to make when you're evaluating limits. So let's take a look at the next one. All right, so I'm gonna ask myself the same question, like, what is this thing the same as? If I try to just sub in -4, I get 16 minus 16, which is 0, over -4 plus 4, which is 0, so 0 over 0. What is it? Let's see what it should be. So I'm gonna factor, I guess. X minus 4, x plus 4. Difference of squares is about to be such a big part of your life, so make sure you're up on that. So this is going to simplify to x minus 4, but I have to put in the additional restriction that x is not -4. I have to put in that restriction because it needs to be exactly the same thing after I algebraically simplify it. So, but x minus 4 has no issues, right? There's no reason that you can't substitute -4 into x minus 4. So I'm going to say right off the bat, g of -4 should be -8. Because if I take -4 and I sub it in here, I would get -8. Let's look at the graph, which is just more evidence that this thing should be -8. So when I graph this, so x minus 4. So let's say that's -4. I guess that's 4. Like this. Now, when I get to -4, I know that there's just going to be a hole in the graph, or a removable discontinuity. It's going to be down at -8. Open circle, like that. There's no reason. It should have been filled in, right? And the value you would have filled it in with would have been -8. Now, the reason is because the limit as x approaches -4 of g of x is -8. But we're trying to just, like, think like a more intuitive way. Like, don't focus on the math of it so much. Focus on the, like, perfect world scenario. What would it have been? All right, let's leave this one. I'm gonna graph it, I think. So really the only important, well, there's a lot of important points, but the only, that's not vertical. The only really important point is at 5, at x equals 5. Okay, so here's 5. And then if I plug in 5 to the, so when x is less than 5, it's just linear. It's 2x minus 3. So if I plug in 5, I would get 10 minus 3. I would get 7. So what I'm going to do is at 7, I'm going to put an open circle because I'm going to get close to that, but I can't get there. And then it has an intercept of -3. So let's say that's -3 and just kind of go for it. I had to curve a little there at the end. That's a classic thing. I should have drawn it and then labeled it. If you're ever in a position where you have to like connect 2 dots on a whiteboard, step 1, draw the segment. Step 2, put the dots. That's the way you do it. All right, this other thing, we've seen these before. This is a parabola where the vertex is 5, 7. So if I drew the entire thing, it would just have its vertex there and it would open down because of the -2. But instead, I'm going to start there, and I don't really care about the details of this, so I'm just going to do this kind of thing. All right. Any reasonable person would look at that graph and say, someone should have filled in that point. So I'm going to say that h of 5 doesn't exist, like at all. It's not that it's something else. It just like doesn't exist. But h of 5 should be 7. Like there's no reason that it's not. Like as I approach from the left, it's getting closer to 7. As I approach from the right, it gets closer and closer to 7. Why is it not just 7? Like why would you define a function this way? Mostly so you could ask these kinds of questions. And then let's look at this one. So this one is weird. It's not that the function has no discontinuities. There's nothing weird about it. It's a nice, continuous, smooth function. The issue is -infinity is not really a number. It's a concept. And you can't substitute a concept into a function. So I'm going to graph it. And well, those are just axes. I didn't graph it. I'm going to graph it. Maybe I'll use a different color. Why am I don't know. Just seemed right. To distinguish it, I guess. E to the x. It's a distinguished function. All right, look at that thing. As x goes to the left, as you go toward -infinity, what happens to this function? It just keeps getting closer and closer to the x-axis. So if you could substitute -infinity, substitute -infinity, it seems like you should get 0. So what I'm going to do here is I'm going to say that k of -infinity, I'm going to put that in quotes because like it doesn't really make sense, should be 0. Like you should get 0 if you sub in -infinity. It doesn't make sense to sub in -infinity, but if you could, you definitely should be getting 0. So what did we do to figure these out? Well, I used some algebra to simplify, which is super common. You're going to do that a lot, like more than anything else, you'll probably do that. I also looked at graphs, because graphs can give you really compelling arguments for why something should be something. Like if we go back and look at either of these graphs, both of them very much support the notion that g of -4 should be -8. H of 5 should have been 7. Like these are things you get just by looking at the graphs. Anything else that we used? Not really. Simplifications, looking at graphs. All right, I'm going to cut this video here. I will come back in another video, obviously, and we're going to keep going. So hope you're finding these helpful.